Log on, tune in, find out. Another good idea from Cambridge.
Well, it's a great privilege to introduce again Professor Gareth Jones, who is Deputy Vice-Chancellor of the University of Otago in New Zealand, where he's been Professor of Anatomy and Structural Biology since 1983. He's held university appointments before that in the University of Western Australia and University College London. He's a visiting fellow at St Edmunds College, Cambridge here, and an adjunct professor at Liverpool Hope University. In 2004, he was made a companion of the New Zealand Order of Merit for his contributions to science and education. He is interested in various areas, particularly in bioethics and also embryology and neuroscience. And he writes as a Christian, and we're particularly pleased that he's going to talk again now on this topic, genetics, plasticity and personhood. The brain in the 21st century. Thank you.
Well, I hope you feel you haven't had enough problems today, because I'm going to introduce you to a few more. At least I hope you feel that they are problems. I won't have been very successful if I don't introduce a few more. Okay, in terms then of this first area, the world of contemporary neuroscience, I just want to take one area, which is an area that we haven't really said very much about, and this is neuroimaging, the world of functional magnetic resonance imaging. The thing about this is, as I think we have touched on before, it has a potential to decode an individual's conscious experience based solely on non-invasive measurements of their brain activity. And some people refer to this as brain reading, and I'll say a little bit more about that shortly. And if you read this general literature in this area, it's really becoming more and more prominent. Because in one area anyway, an area which tends to hit the headlines because of its apparent ability to detect deception. But that, of course, is only the tip of the iceberg. Because underlying this ability is the premise that our inmost secret thoughts and feelings are located in our brains, and they can be investigated by external observers. And so you've got the growth of a whole new area of sort of disciplines: neuromarketing, neuroeconomics, neurotechnology, and something I was just touching on this morning, neuroenhancement. And then a whole area in bioethics is growing up called neuroethics. I think it has more questions than answers at the moment, but you can see where things are heading. But from our angle, where does this leave traditional Christian thinking? What has happened to the soul or the heart? Now, we've been touching a little bit on the soul before, but in terms of what we've got here in neuroscience, what's happened to them? Where do they fit in? And because, of course, both of them fit very prominently into much Christian language and Christian thinking. How often do you hear theologians referring to the brain? How often do you hear the brain mentioned in church services? How often do you sing songs or hymns that have the brain in it? Have the soul in it, that have the heart in it, but how often have they the brain in it? What is the relationship between the brain and the human person in Christian thinking? Or is the rise of neuroscience an embarrassment to Christian and more general religious understandings of the human person? And where do Christians think the human choices originate? Now, we've been touching on some of those things, and I'm not going to say much about that. Obviously, there are a whole lot of answers from many different strands within Christian thinking. But the one thing it seems to me that you have to take into account is neuroscience. Okay then, where then is neuroimaging taking us? To what extent is it possible to decode mental states from brain activity in humans? Now, that was a task undertaken by John Dillon, Haynes and Geraint Rees in a review of neuroimaging in mid-2006. And they asked the question, is it possible to tell what someone is currently thinking based only on measurements of their brain activity. They then go on in their review to carry out a detailed analysis of methodological considerations, which of course don't concern us. But they conclude by stating this: decoding-based approaches show great promise in providing new empirical methods for predicting cognitive or perceptual states from brain activity. Now that might sound a somewhat dry conclusion, but it points in the direction of being able to predict behavior from neuroimaging data. And obviously that itself may raise a whole range of ethical concerns quite apart from any other concerns. And so the existing literature then points towards the ability to detect the neural correlates of an increasingly wide array of conditions and traits. These include things like conscious and unconscious racial attitudes, conscious self-regulation of emotion, various personality traits, personality disorders and psychopathic conditions. You might be able to detect serious criminal tendencies or drug abuse of various sorts. And you might be able to detect people's preferences for various products like well-known drinks and the decision-making process itself. Now all of these, in their quite different ways, are illustrations of brain reading. Now there's no doubt that some of them raise considerable issues for society. Some of them, of course, are highly controversial. But it seems to me that they also confront Christians with the centrality of the brain in any model that they construct of the human person. Now one imagines it might be possible to pinpoint the part of someone's brain, the points that are active when that individual initially makes the crucial decision to become a follower of Christ or to go down some other religious pathway. You might be able to detect numerous moral and spiritual choices that are being made. Where are they being made in the brain? If you forgive others rather than hold grudges against them, you might be able to detect something about that in their brains. And of course, exactly the same comments would apply to the act of praying. And it might even be suggested that different sorts of prayer would be associated with different brain regions. Now, of course, quite a bit of this is speculation at the moment. Not all of it, but quite a bit is. And you might, of course, ask, is this profitable speculation? Perhaps it's not. But I think the point remains. We shouldn't be surprised to find neural correlates with what we consider are fundamental activities within the Christian or any other religious community. You see, by exactly the same token, we will never find equivalent correlates in any other organ, no matter how important some of them are. There are no correlates like that in the heart, let alone the gut or the kidney or whatever. So that itself might be of interest and relevance to Christian theology. Now, of course, the simple act of finding neural correlates for certain behaviors or attitudes is irrelevant when it comes to causative factors. Simply because, let us say, brain region R is active when behavior B is undertaken, doesn't mean that changes in R cause B to take place. After all, the opposite could be the case, that when an individual displays behavior B, region R is in some way modified or is activated. And if this occurs sufficiently frequently, there are significant changes to it. And of course, the interplay between R and B may be so close that the only conclusion you can actually reach is that there is no definitive causative factor. The one feeds upon the other. But I think we have to dig a little bit deeper than this, because the sort of neural correlates that are detected by functional MRI, they are themselves, of course, indicators of cellular changes, like changes in neurotransmitters. And I want to now just give you one or two examples. They're not going to come up with any sort of nice, neat explanation. I'm not pretending that I have one. But they're the sort of studies that are currently being carried out. Now, it's been proposed in a very recent study that the visceral disgust, which is common to human cultures worldwide, forms the basis, of the neural basis for the evolutionary development of what people call moral repugnance. Now, what do we mean by this? Well, visceral or core disgust is said to function bodily purity and integrity. For example, by preventing us from eating contaminated food. So one sees some food which is obviously off, then that's visceral or core disgust. And so what the argument here is that this core disgust is supposedly associated with socio-moral disgust concerning more abstract issues. Let us say things like abortion or homosexuality. So if one is very much opposed to those, you may have a certain moral repugnance, a socio-moral disgust, which of course is rather different from the visceral disgust. Now, the issues that are being brought up here by one or two very recent studies, for instance, shows that one functional MRI study showed that when subjects experience either visceral or moral disgust, overlapping brain areas are activated. That implies that the emotions in some way are related. Now, you can make of that what you like, but at least it is something which you cannot dismiss as of no consequence whatsoever. That was just one example. Let me give you another example. Last year, a paper appeared in the Proceedings of the National Academy of Sciences, and in it, the authors argued that charitable donation activates the reward system in the brain in the same way as do food, drugs, and sex. What they did was to use functional MRI, and they found that altruistic acts, like giving away money, those acts lit up a particular primitive reward system, the mesolimbic reward system in the brain. That explains why it feels good to do good. And the author suggested that performing charitable acts may be hardwired into the brain rather than simply being a product of culture. Now, again, that raises probably more questions than it answers. But it gives you some idea of where some of this work is taking or the sorts of issues that it's raising. Let me give you another example. I said I was going to give you more and more problems if you haven't got them, so here they are. Another study published in Science in June of this year. It used functional MRI to examine the brains of subjects as they chose whether to voluntarily give money directly to a food bank as opposed to watching their money go to the food bank through mandatory taxation. Okay? So they decided to either give money to a food bank, or they decided not to, but they knew it would go to the food bank through taxation. Now, what emerged was that even when the subject didn't have a free choice, as in the case, of course, of taxation, the reward center in their brain still lit up. And the authors interpreted this as showing that pure altruism does indeed exist. And they defined pure altruism as when a subject experiences satisfaction from an increase in the public good at their expense without receiving any reciprocal benefit, such as an acknowledgement of their gift. They also found that the brain activation was greater when the money was voluntarily given. And so what that confirmed for them was that the additional neural reward known as warm glow giving was active. Now, I don't want to take that any further, and once again, it raises more questions than it answers. But what's interesting about this is there were 3 authors to this paper. One of the authors was a neuroscientist. 2 of the authors were economists. And you see, their aim was to draw conclusions of direct relevance to the determination of taxation policy. In other words, what we've got there is an example of neuroeconomics. Okay, but of course we might say, surely acts of kindness and altruism are motivated by compassion and moral feeling, rather than a primitive urge for the good feeling produced by neurotransmitters. Surely we would say we are moved to be altruistic because of a more substantial drive than simply for food or sex. Well, yes, but let's take it further. I think if you go just a short step, you can take a step which tends to dismiss even religious aspirations as nothing more than outpouring of one neurotransmitter or another. In fact, one research group, in experimenting with subjecting the human brain to patterns of electromagnetic bursts that in some subjects stimulate out of the body or other spiritual experiences. So that's what they did. They dubbed this apparatus the God machine, which perhaps is rather a flimsy sort of description. But what they're attempting to do is to mimic the cerebral short-circuiting, which in some epileptics produces religious visions. Now, of course, you can immediately say, well, many people have religious visions who are not epileptics and never suffer from epilepsy, and that, of course, is true. What they found was that this machine's effects vary among subjects, depending on how open the subjects are to religious experiences. And so the question then becomes, well, can it be as simple as stating that people with certain levels, say, of the neurotransmitter dopamine in region X, let us say, have religious sentiments, whereas those with lower levels have no need of religious symbolism? And if we want to be really facetious, we can say, well, if you looked, say, at a bunch of Anglo-Catholics, would you find a certain level of dopamine? If you looked at a bunch of Pentecostals, would they have a different level of dopamine? I'm not being serious about it, but you can see the sorts of ways in which some of this thinking is going. The question is it simply then a matter of neural organization? And is that in turn an expression of genetic predisposition? Could you say that what we need are neurotransmitters, not prayer? Now, that of course will seem like a rerun of the old neural determinism argument in very modern guise. And the sort of comments that I've made earlier about causation, they apply here as well, of course. You don't know which comes first. The only point that I want to make is that these days, this whole issue has become far less hypothetical than it would have been 20 or so years ago. Because, you see, what we're getting to is that we are coming close to being able to use these sorts of neurotechnologies to do a variety of things. If we can predict how someone will act under certain circumstances, we have the ability to intrude upon their privacy, as well as to use the data to scope sophisticated, say, marketing campaigns. We might even say evangelistic campaigns, but let's keep it to the marketing campaigns. Because you see, the next step would be to modify people's brains by using drugs that would increase or decrease the levels of chemicals, such as neurotransmitters, in various targeted brain regions. Now, you could use intrusions like this either for therapeutic purposes or, as I touched on this morning, for enhancement purposes, or to modify decision-making choices and abilities. See, as with all technologies, there is room for good uses and there's room for evil uses. But I'm not so much concerned with ethical issues in this talk, but with the underlying concepts. To what extent have Christians begun to come to grips with these developments? Because they have major pastoral implications as well as fundamental conceptual ones. Let me just touch on one or two pastoral implications. For quite a number of years, there's been a drive to find drugs to improve the functioning of people's brains, to combat everything from depression and anxiety disorders to forgetfulness, sleepiness, etc. One person has described this as the world of super Prozacs, in which almost every behavioral disorder becomes amenable to drug-based treatment. Consider, though, the use of Prozac as an illustration of a class of drugs that affect the activity of a particular neurotransmitter, which is serotonin. Now, these drugs generally act in the emotional centers of the brain, and so they influence emotional responses. They make people more outgoing, and they can be used to combat depression and anxiety disorders. Now, the question that we have, I think, is whether this might be of relevance to the lives of Christians or to the lives of anyone with religious aspirations. Now, I think it has. Consider the following. Jane wanted to die in spite of concerted prayer and counselling. After taking Prozac, she began to feel normal and could experience God in ways previously unknown to her. Trevor's life was dominated by severe depression, by outbursts of anger. Following a number of weeks on Prozac, he was transformed, and he felt as he had just a few years previously when he became a Christian. Now, for people like that, medication is a fact of life. It allows them to experience normality, and normality, of course, has its highs and its lows. And what I think this suggests is that even people who are deeply committed to God may have no hope of a normal life without this sort of assistance. Now, of course, a statement like that, for some people, is profoundly disturbing. After all, can a pill do what we normally think only the Holy Spirit can do? Why do drugs work, at least sometimes, when prayer and counselling seem to have failed? Should we conclude that spiritual problems may be more effectively cured by neuroscience and psychology than by traditional spiritual means? Now, obviously, I'm deliberately putting things here in very black and white and very harsh terms, but because I think they're the things that we need to be thinking about. Now, it doesn't matter how we answer these questions, but I think what we come to is that there is this inextricable link between the biochemistry of the brain, who we are as persons, and how we relate to each other and to God. As we know very well, certain brain regions are associated with certain functions, things like goal attainment and anxiety. And so emotional and mental health requires appropriate function of these brain regions and their connections. And so to some degree there is a neural basis for emotional well-being. And so when aberrations occur, when things go wrong, the appropriate neural systems have to be targeted. And so one can say that in these sorts of terms, Prozac may allow certain individuals to achieve freedom from emotional dysfunction and specific psychological disorders, and therefore they may enhance that individual's ability, in a sense, to be themselves, to be what they could be. And I think this becomes very important for an individual whose actions stem not from understanding, but from compulsion, or as a means of dealing with feelings of guilt and failure. We hear very much into a pathological arena. And to the extent that things like guilt, feelings of failure, actually stem from emotional affliction, I think it's appropriate that they are tackled in whatever way is best, including sometimes the use of things like Prozac. Obviously, all this has to be done in a very nuanced and careful way, but I think there are situations like this. Michael Boyvin has commented that the usefulness of Prozac results, and I quote him, not because our experience of God is nothing more than a brain state, but because God created us as physical beings within which the brain serves as the final omnibus of our thoughts and emotions relevant to Him. And so what I'm saying then is that it appears that at least for some people, in some situations, Prozac can have a role in healing emotional afflictions because we are persons who are part of God's physical creation. A creation, as we know, that is sometimes maladaptive, things go wrong, and is in need of redemption. And so what I would say is that something like Prozac, and there are many other drugs like that, it provides perhaps a limited means of redressing brain systems that have been warped by many forms of maladaptation, and which by itself is one means of effecting at least short-term restoration. Now, of course, underlying what I've just said is an assumption. And that is that the use of Prozac and similar drugs is to remedy a pathology within the brain. Its intention is a therapeutic one. I'm not getting into any of those real enhancement areas I was touching on this morning. It's a therapeutic one because the individual is ill. But to come back to my earlier question, a pill may work because it's rectifying aberrant synaptic function, where things have gone wrong in the connections between nerve cells. Just, of course, as a pill may work to correct malfunctioning heartbeat. But, of course, my antithesis of a pill or prayer is unhelpful. It was deliberately intended to be. What I would say is that any drug regime should only be resorted to within a context provided by prayer and spiritual discernment. And that, of course, is where the Holy Spirit comes in, and where spiritual judgment comes in. And so in determining the best course of action in intractable situations, such as the ones I've touched on, we need to see the individual as a whole person in relation to God, and also as part of a community of faith. But of course, there's a proviso here. And this is that drug-based approaches to emotional illness are just one means of approaching the illness, and they constitute a direct means of modifying the brains, and hence the individual's responses. And I don't think that modifications of this nature are ever without their dangers. They do have their dangers. And of course they leave untouched what may be social, community and spiritual problems. Therefore, to use them aright, it seems to me that the longer term solutions need to take account of that whole relational context within which the individual is seeking to live. Because all these indirectly influence neural and mental functioning. So what this is saying is that we are bodies, each with multifaceted dimensions, and with our brains as one of these facets. Let me now just give you a particular example. I did allude to it in the question time this morning. It was actually one that was brought to my attention by this course last year. It was one of the delegates who knew about this person, and her book had just been published. It's the story of Kathy Wield. And I think she stands as a modern example of a Christian who has suffered extreme anguish due to depression. Now, her story raises far more questions than it answers. It's an enigma, but it provides, I think, a rare and a very valuable insight into the life and struggles of a Christian suffering from extremely severe depression. She writes, "My life journey took me through a single but continuous 7-year episode. It was a terrible nightmare of torture and imprisonment. I am one of the fortunate ones to have survived and recovered." End of quote. Kathy Wield was a mother of 4 children. She was working as a junior doctor, and she suddenly found herself very down, and she realized she was suffering from depression. What followed that was 7 years of extreme mental anguish, which no amount of medication or therapy could ever touch. She had repeated bouts of electroshock therapy, or ECT. She was having them for many times, at about once a week. They made a bit of a difference, but not much. And the difference was always short-lived. During those 7 years, she was admitted to 5 different hospitals, and they were actually all hospitals in the south of England. She was under the care of 7 consultant psychiatrists. She was put on 13 different classes of drugs, and she had psychotherapy at least once a week. For 2 out of the 4 years that she was in hospital, she was there on enforced detention because she was a danger to herself, and she tried to commit suicide on innumerable occasions. 5 years after she was first diagnosed with severe depression, Kathy Wield was referred for surgery for mental disorder, which is the modern name for psychosurgery. discrete lesions were made in one part of her brain. And this was done in Dundee. The surgery took place 18 months later. 8 days after the operation, Kathy's depression suddenly lifted. And I quote her, "I believe that God had stepped in and his healing touch had been upon me. No one could give me any medical explanation for what had happened, but whatever anyone believes, there is no doubt that truly something remarkable had put me back into life without the need for any of the extensive rehabilitation program which had been planned." End of quote. Now, there are no simple answers of any description in this particular case. There are no answers medically. I don't think there are any clear answers spiritually. Yet I think it very compellingly illustrates that something done to the brain can have major consequences for good, certainly it was for good in this instance, in a person's mental state. In other words, things that the brain and the mind are not separate compartments. You see, I think it's very easy to dismiss all forms of direct surgical intervention in the brain, certainly for behavioral reasons, as in this case. But I think it would be foolhardy to do that on theological grounds. So, one could go on at great length about that story, but I think I've said enough just to illustrate the complete enigma about something which is probably relevant to what we're discussing. Okay, I now want to move on to what a personal model of the brain. Now, I was going to say something in discussion after Peter's talk when discussing a machine model of the brain, because I'm going to divert slightly from this. You'll see why. And we'll see how we get on anyway. Now, it's been known for a very long time that certain brain regions can have grotesque ramifications, and we saw an illustration this morning about Phineas Gage. What I think all these examples of brain damage do is simply, they tell us that our brains appear to make us the sort of people we are, in a way in which our liver, our kidneys, or our pancreas don't make us the sort of people we are. In other words, there seems to be a much closer relationship between my brain and me than between my kidneys and me. Let me just give you two very recent examples of issues here. They've come to light very recently some examples of therapy-induced damage to the brain in people with Parkinson's disease. So people have got Parkinson's, and they've been treated with dopamine enhancers, which is fairly standard. But there have been some examples where there seem to be excessive levels of dopamine in these patients' brains. And the result is that these patients become compulsive gamblers and obsessive pleasure seekers. Not the sort of thing you want when you're trying to cope with Parkinson's disease, especially if you were highly respectable people beforehand. Now, there's no definitive evidence for this particular link, but it's not an unreasonable possibility because dopamine is associated with various addictive behaviors. Now let me give you another recent example. There's been a very recent study which has shown that patients with damage to the ventromedial prefrontal cortex, that is the one here just behind the forehead, that these people make unusual decisions when faced with a moral dilemma, because it appears that they have impaired emotional responses that affect their moral intuition. And so what's been shown here is this sort of scenario. Let us say that you are with a group of people, but you are trying to escape or hide from a band of killers. So you're in a hiding place. There's a band of killers out there, and a group of you. But unfortunately, in this group, you've got a baby, and the baby is crying. How do you respond to this? If the baby cries, you'll be found and discovered by this band of killers. Well, it seems that people with normal responses, they will be torn between concern for the baby and the baby's welfare, as opposed to their own welfare, and they will not want to smother that baby or kill that baby, even though it may save their own lives. And that seems to be the way in which normal people react. So they're really torn between the two situations. So in this case, then most people will face an emotional aversion towards taking the life of that baby in order to save their own lives. And they struggle to make a utilitarian decision to kill the baby to save the others. But the patients with these particular lesions, they are unmoved by this sort of emotional aversion. And they tend to choose the utilitarian option of killing the baby without too much thought. So that's then an example of what might happen with a particular damage to a particular region of the brain, where then moral intuition is actually affected. Now, it's clear from these pathological examples that the relationship between injury to the brain and aberrant behavior is compelling. Brain injury A may be the direct cause of behavior A. And that relationship holds regardless of the theological stance or the moral values of the injured individual. And of course, medication can act in the same way by elevating or depressing the levels of certain neurotransmitters like dopamine. But underlying all of this is the dictum that if an individual's brain is changed, that individual will be changed, as if the machine at the core of our being has been adjusted. So that's the machine type of model. And if that's so, what are the implications for our view of ourselves as beings of significance? So the question is then, are we little more than neural machines writ large? Now, I think these are very understandable concerns for most people, but they're based on the machine type of model. Now, it seems to me the problem with the machine type of model, and I accept it in many ways, but is that it is fixed and rigid. And I think this model is misleading, not because it fails to do justice to Christian aspirations, but to scientific ones. See, what I would want to argue is the brain is not just a machine. We can describe it in many ways in machine-like terms, but in some ways it's the opposite of a machine, because it's highly responsive to numerous environmental stimuli at all stages of life. So what you have, I think, are two-way interactions between an individual's brain and the worlds both internal and external to that individual. And I think they point to a very rich, multidimensional context. I'll come back to that in just a moment. Now, in no sense can the brain be isolated from an individual, in the way in which the heart can be. Neither can it be replaced by another brain without destroying the integrity of the individual as the person that he or she is known to be. I now want to undertake a thought experiment. We've got 4 friends. Now, unfortunately, they all are not in very good health, as you'll see in a moment. So we've got these 4 friends. Paul has had a kidney transplant. Mark has had a heart transplant. Ruth has an artificial hip. And Crystal has a brain transplant. I said they weren't in very good health. How might we respond to these 4 individuals? Well, we know them all quite well. Now, I think we have no problem in recognizing and relating to the first 3, Paul, Mark, and Ruth. And we'd probably say they're far healthier than they were before their respective operations. And we may say they're back to their own selves, because their illnesses were reducing them to invalids. Now they're normal again. Well, what about Crystal, the one who had the brain transplant? She's no longer the person she once was. Her body is the same. We recognize her facial features, but her personality has changed. If we had known Sandy, whose brain Crystal now has, we might say she's more like Sandy than Crystal. We still have Crystal with us, but we've also lost her. All the experiences that made Crystal the person she was and that we knew, they've all gone. The memories have gone. The values and interests have changed. And Crystal is a changed person. Now, for the biologist, kidneys, hearts, and hips serve machine-like functions. Doesn't matter how sophisticated they are, or, as in the case of the heart, what symbolic significance they had. There was one situation where a couple of years ago I actually referred to the heart as a pump, and the audience was full of theologians. And one theologian was extremely upset with me that the heart is the most important thing in Christian thinking. It's not just a pump. Well, we didn't get very far in our discussion. But you see, from a biological standpoint, these other organs can be replaced by machines, either temporarily or permanently. But of course, you can't say the same for the brain. And you can't say the same not because we have a poor understanding or primitive technology, but because of what the brain is. Now obviously, I've given you an outlandish picture of a brain transplant. But I think it helps to make the point that it's wrong to regard ourselves as consisting of a brain, various other organs, and perhaps an immaterial something that constitutes the real me, whether we call it mind, soul, or whatever. And in a sense, from a biological standpoint, our brains represent us. They make us what we are, but only in the sense that we also make them what they are. You see, that's why I think there are limitations to the machine-based model. And I would rather refer to a personal model. This, of course, doesn't mean that we can do nothing to the brain. It's obvious that we can operate on the brain, treat hemorrhages, remove blood clots, tumors to be removed, or whatever. We can, and as you've seen on a couple of the previous talks, electrically stimulated in various ways. You can even introduce fetal grafts into the brains of patients with Parkinson's disease or Huntington's disease. And of course, that whole range of implants is beginning to appear. But as long as the damage isn't too extensive, and depending, of course, on which brain region is affected and is involved, then the individuals after the operations are clearly the same people as they were before them. But there, of course, are dangers here, because any intrusion into the brain is an intrusion into the center of what we are as physical beings. I now want to, in a sense, go on a little bit more with the sort of the machine and the sort of personal type models. I'll pick up on neuroplasticity. Now, you see, in developing a personal model, that I call a personal model of the brain, I think we have to look more closely at the brain itself, and in particular at one of its features, which is its plasticity. Now, plasticity is simply the term used by neuroscientists to denote flexibility and pliability. And I think as soon as we do this, we begin to realize that we as persons, that what we are as persons isn't laid down once and for all in the genome. Obviously, the basic ground plan for an individual's brain is spelled out in the genome. But the detailed patterns of synaptic connections that link its innumerable nerve cells, they are fashioned by a host of influences throughout life. And so if you look at the developmental period of the brain, what you have there is an initial overproduction of neurons, and when there is massive competition between them, with only about 50% surviving into adulthood, and that's what's normal. I think the fascinating aspect of this phenomenon that it's the external environment that has a crucial role in determining which synaptic connections between neurons persist, and therefore which neurons survive. And so if you look at the newborn, I mean, Bill will know far more about this than me in the visual system and visual stimulation. Eyes of the newborn must receive visual stimulation from the external world during the early months of life in order to fine-tune the structure of the visual part of the cerebral cortex. Not only this, this stimulation must occur during quite specific critical periods of brain development. And so what this is saying is that very often, external inputs have an extensive influence on the developing brain, and they interact with internal drivers to mold the end product that is eventually the adult brain, and therefore the adult individual. And it's really because of this close interrelationship between the developing brain and extrinsic factors that normal development can all too easily be disrupted. After all, if there are changes to the environment, delays in the arrival of sensory impulses during development, all these result in a brain organization which is different from what would have been the case under other conditions. And so numerous influences during development can have devastating consequences for a child's subsequent intelligence and behavior. And this is where, concerns about alcohol during pregnancy come in, with the fetal alcohol syndrome simply having huge changes to the brain and the subsequent individual. And of course, you want to look at the other side of the coin. This is why you have to play Mozart to your developing fetus. Now, whether that has any influence whatsoever is another matter. But you can see the point here. So a stimulating environment can also increase the complexity of neural organization and therefore alter many aspects of the behavioral repertoire of the growing individual. And so what I'm saying here then is that the specific fine-tuning of the synaptic connections in any given brain will contribute substantially to that individual's uniqueness and personhood. And this fine-tuning occurs initially over the crucial period from 6 months gestation to 2 years postnatal. And then throughout life, as synapses are lost and replaced in all parts of the brain. And so the possible variation that you get is well nigh infinite. And the connections are modified in response to all the experiences that constitute our lives as individuals. And so what I'm saying is that what we are as people emerges from this ongoing dialogue between the neural and the genetic material we inherit, the worlds we occupy, and the worlds that we ourselves construct. And extensive plasticity like this makes possible the enormous range of human beings' intellectual abilities and spiritual gifts. And I think it's because of these sort of neural capabilities we can be human persons who have responsibility, creativity, and responsiveness to each other and to God. Remove neuroplasticity, many of the marks of true human personhood disappear. That's the sort of thing that you get to some extent in some real problem areas. So what I'm suggesting here then is that our biological uniqueness as individuals mirrors our theological uniqueness as persons created by God. And I think the relevance of this for our present discussion is that so much of our biological uniqueness stems from the characteristics of our brains. Characteristics, of course, that in turn come from genetic inheritance, numerous facets of our pre- and postnatal environment, the way in which we respond to the world that we encounter, the attitudes that we ourselves display towards fellow human beings, and what we make of God's revelation in Christ. Now, I think as we just begin to think along these sorts of lines, I think what they potentially open up are exciting areas for cooperation between neuroscientists and theologians. Because I think what we are beginning to glimpse here is a means of appreciating theological concepts using our understanding of brain function as at least a guide. Okay. 2 more sections. I'll only deal with one, looking at the time. I'll say something. I'll do something on neurogenetics. All right, let's move into another problem area. You hear all the time about IQ genes, gay genes, poverty genes, etc., etc. There are probably spirituality genes and genes for prayer if you again want to be speculative. But if there are, I think there are probably agnostic genes as well, but I've never heard anybody talking about those. But the argument is always, a lot of this is just silly. But the argument is always the same. These genes cause us to act in certain ways. And from that, we are told there is no escape. Certain genes lead to certain behavior patterns, and some genes lead to disease. And again, there is no escape from any of that. And again, there's some truth in some of that. But I think among many of the repercussions of these alleged associations, the message for Christians is often a grim one. Because what it's tending to say is that they undermine central elements within our responsibility as human beings. For instance, if I have no choice but to be aggressive, I can't respond to the call of Christ to be a peacemaker and to love my neighbour as myself. And it might be that the fruits of the Spirit can't manifest themselves in my life, not because I'm being unfaithful, but because I'm genetically inclined to be otherwise. At least those are the sorts of things that, and the flavour of things that you get. How do we respond to these sorts of possibilities? Well, I think the first thing to say is the link between individual genes and behaviour is far more complex than suggested by the gene for X scenario, whatever X might be. And in part, it's due to the presence of multiple genetic factors, the substantial role that's played by environmental factors, and the interaction of the environmental factors and the genetic factors. And of course, genes might also be switched on and off in response to a whole lot of pressures during development and then later on in cellular life. And so a gene or even a set of genes will rarely be the only cause of a particular condition. Because in the end, the pathway between a gene and an individual who, let us say, scores higher on an IQ test, or perhaps an individual with an aggressive personality, the pathway is very indirect. Now, it's not to argue that genes have no influence on behaviour, they certainly do, but it's not stronger than that. Let's just look very briefly at just one or two examples, and I'm not going to say much about them. The so-called IQ gene is a totally misleading concept with really no basis in scientific reality. After all, IQ is influenced by many different genes, quite apart from the validity or otherwise of IQ. If, for the sake of argument, the heritability of IQ is 0.5 in Western populations, and if there are 25 genes associated with this variation, then each will be associated with 2% of the observed variation in IQ. Now, that small effect can't be distinguished from chance fluctuation. So, when you look at some detailed genetic studies comparing groups of children with substantially different IQs, they've led to the conclusion that, and I just quote one, some differences in the frequencies of particular alleles of particular loci have been found between high and average IQ groups. Now, what does that mean? Well, what it's saying is that these sorts of studies at least open the way for determining how genetic differences might lead to differences in IQ. But this is very far from finding an IQ gene that can be manipulated to increase intelligence. And then a great deal of attention has been given to a genetic basis for antisocial behavior, and therefore for legal and moral responsibility for criminal behavior. The thing is that relatively few genetic studies have actually been done in this area. But there was one study on a particular family, and that family had a high incidence of violence and serious crime among its male members. And this study did claim to find an association. And the focus settled on a gene responsible for producing a protein, monoamine oxidase A, MAOA. And that's involved in regulating a neurotransmitter, serotonin, in the brain. Now, the male members involved in aggressive behavior had low levels of MAOA in their bodies. They had lower than average IQ, and they had a defect in this particular gene. A subsequent study by other researchers investigated this link in a group of 500 male children. And the data of these workers pointed in the same direction. But only if the individuals concerned had also been mistreated and abused as children. So what emerges then it's the interaction between the genetic variant and the environment that is important. It's not saying that gene is not there and has no effect. It's not saying that at all. But in the end, it's a more complex situation. And then there was a celebrated legal case a few years ago in the United States. And the association of a point mutation in this MAOA gene with antisocial behavior, it was used in the defense of Stephen Mobley, who shot dead a pizza store manager in 1991. Mobley's lawyers requested that he be tested for this genetic abnormality on the grounds that this might explain his actions. The defense, though, wasn't accepted, and he was executed in 2005, so of course we don't know what the situation was. Then there's another approach in the antisocial area. This is based on results from mice with targeted disruption of neural nitric oxide synthetase. because these mice are particularly aggressive. And the aggression appears to be associated with decreases in the turnover of serotonin and its receptors in brain regions that regulate emotions. But the same strictures apply here as with neuroimaging. What causes what? What comes first? Causality is only inferred from this association, and the complexity of the gene-environment interaction is quite daunting. And so this leads to the distinct possibility that it may never prove possible to quantify the contribution of just one or two factors. And what makes the situation even more difficult is the temporal factor, or the time factor, in the effect of environmental factors in any underlying genetic predisposition. I think as time's going on, I'll go over the gain gene. I wasn't going to say very much about that. I'll go over the God gene as well. I'm not sure if any of us have got the God gene, but I don't think it really helps us. Putting all this thing together, it seems to me that the world of neurogenetics points clearly to the conclusion that aspects of our character and our personal identity, of course, they do have a genetic basis. And that's not surprising, because we are our bodies and our bodies are us. And of course genetic factors are involved, even at the deepest levels of what makes us the people we are. But it seems to me this in no way threatens the conception of a person as a rational being, who is capable of taking responsibility for ourselves as free agents. Neither do I think does it hint that we cannot act as God's agents and stewards in his created order. And I think we also need to say that our genetic building blocks are far from unalterable. What they give rise to is intimately affected by the environment, both the internal environment down to the levels of cells and tissues, and also the environment external to the body. And I think it's up to us as persons to determine what we do with both our abilities and our restrictions. No matter how genetically based some of our restrictions may be. It seems to me that we are to use the resources at our disposal rather than view ourselves as prisoners of our inheritance. The information that's provided by behavioral genetics should be used to increase our understanding so that we can come to terms with the behavioral conundrums with which we are all confronted. Because in the final analysis, it is we who decide how we live and act and what we believe. Now, it's true, of course, that for some, this freedom is severely restricted. And it's restricted due to developmental restrictions and sometimes, of course, to later brain injury. But most of us are in a position to play a causal role in how we live and what we do. Question is, though, will this change in a future world if the genetic makeup of individuals is totally known? After all, we might get into a world where genetic chips might be available, and these could be used to read out our individual genetic makeup. And in that world, theoretically, everything that could be known about us genetically would be known. It would just be a matter of reading out and then analyzing our genetic blueprint. Information would be available on the functioning of our kidneys or our brain, the chances of us developing a whole range of cancers or heart disease, and even our ability to cope with stress or our proneness to depression. And that, of course, is the realm of potential genetic determinism. And some argue that we would then become prisoners of our genes. We could do nothing but live out what we were predestined to be. On the other hand, though, even in that extreme situation, genetic determinism wouldn't work out like that. Genes wouldn't act in isolation of innumerable environmental forces. In the end, it would be up to individuals to decide what they were going to do with the knowledge available to them. Because after all, in the end, whether it's in this area or any other area, a predisposition for a disease or a behavioral trait is not the same as having that disease or expressing that trait. There's a big gulf between the two. Okay, well, my time is up. I was going to end up with something very provocative, which is, I don't like use of the term heart very much in Christian theology. And I was going I don't think I'll say, well, all I'll say here, and I'm not really going to go through this, the one thing that strikes me very, very much, a lot of church services, is the way in which pastors, ministers, songs refer always to the heart. And I'm fascinated to know what people who use this actually think. Because generally when they talk about the heart, they're actually meaning the brain. But they never mention the brain. And it seems to me that if we use the term brain far more than the term heart, then we would actually understand far more. But I won't say any more about that, and I won't try and reinterpret some of Jesus' sayings, but I think sometimes if they were reinterpreted in terms of the brain, rather than in terms, of course, of the language that was used from that particular culture, it might actually mean far more to us. But I'm rather biased in favour of the brain. I think I better stop. Thank
you. Any questions for Gareth? Jessica.
Identical twins surely have identical DNA and are identical biologically, but are not identical neurologically. Surely, the first point, they are proof are needed that genetic determinism cannot be a complete art. And secondly, is a question, at what point in their development do their brains diverge and why?
You've got an identical twin sitting behind you. I don't know if you want to say anything. I mean, I'm quite happy to comment, but you know how what you and your identical twin are like.
I know that fairly early there were differences between us, but they were not only genetic. I mean, my brother stole blood from me before birth, and so that when we were born, he was heavier than me and smarter and learned things more quickly. And so when we invented our twin language that other people could not understand, and then he learned English, and if my parents wanted to speak to me, they spoke to him and he translated. So there were differences pretty early, but of course I can't say how early, but even though the differences were not genetic.
I would say probably the differences actually start during gestation.
Yeah.
So you say they're not born with identical brains?
Because there will be different environments even within the same uterus. Yeah. I mean, they may be minor rather than major, but they will be there. But I think what's fascinating about identical twins, it gets us, of course, onto a totally different area, and that is clones. You know, people go on and on and on about how awful it would be to clone. I mean, this is reproductive cloning now, and we don't want to get into that one. I'm quite happy to. Because they wouldn't be unique. But of course they're going to be unique. They are actually going to be less identical than our identical twins. And of course they're going to, because they're not going to be actually identical genetically. But then they are going to develop differently, just as identical twins develop differently. And identical twins are different persons. And they will be different persons. So I would say that the differences would start very, very early on, but it will become more noticeable.
Rodney, I'd just like to comment on that. I mean, you're right that the person who asked the question is right that the brains diverge in structure very quickly with identical twins, and as soon as their experiences start to diverge, their brains start to diverge.
Yeah.
So as soon as Peter goes to this meeting and his brother is at a different meeting, they have different experiences, different synapses are modified, they have different memories, that's realized in the weights of synapses and the structure of neurons, and those brains are different. The genes just set things up and get them rolling and prepare the way for plasticity. But those plasticity events, changing the strength of connections between neurons, they are determined by the experience that we have. So Peter's brain is very, very different from his brother's brain. And that's why he has different memories, and that's why he has different emotional responses to certain situations. And that's all epigenetic. That's all above the level of genes.
Yeah, and that sounds very defeative for determinism, really, doesn't it? Genetic determinism, and things like all the other things you had that you didn't go through, genes and the rest of it.
And that too, I think, is why I don't like to take the machine model too far. Because in the end, brains are not like machines. And there are, at certain levels, it is very useful to describe them in these terms. But in the end, it's because they are so malleable that they are different. I mean, the way in which, Rodney as a washing machine or whatever it was, it'd be a very different washing machine if it was more of this personal model.
Yeah, Bill?
Well, I would just say, I actually wanted to ask you a question, Gareth. You went over this fairly quickly, this kind of key point in the talk where you said that you wanted to get away from the image of the brain as a machine because, and as nearly as I can tell, what I heard you say was because the brain receives these inputs. It's constantly interacting with its world and it receives inputs. But machines can receive inputs too. Robots and computers receive inputs. They have all those keys on them, and we type on those keys, and that's the computer's sensory system. But robots can have visual systems. I just drove a rental car where the silly windshield wipers come on when it starts raining without me doing anything because they sense that the windshield's wet. And I looked at my traveling companion and said this car has a somatosensory system. It has inputs. It senses the environment and it responds to them. And there are machines that are being built now that have the capability to learn, to plastically change their internal structure in response to things they experience in the world. So the neural network is an example of one of those things. So it's a different breed of machine. It's a different kind of machine that's coming. But they're machines that have real brain-like capabilities. And I'm not sure that I would personally be able to dismiss the machine, where a machine is redefined to include interactions with the world and to have the capability to learn. Suddenly, I don't know that I personally could readily dismiss the comparison between brain and machine.
But that, yes, using, machines of that sort, I think sort of alter the sort of analogy, at least in my way, that we've got. Because you've now, in a sense, almost saying that we've got machines which act more like brains.
Scott?
And I think that just emphasizes to me the really critical point in your lecture, which was this idea that causation is two ways. Just because you have a certain biological structure, okay, that could relate to behavior, but behavior might have the backward cause towards the biological structure. I'd be a little concerned if they start to do this neuroimaging and they see a structure and say, well, you're locked into this way of behavior for the rest of your life, without really realizing, hey, behavior can rebound back to create this structure. So I think it's just an important point to note.
I agree. Dennis?
Well, no, just adding to that, I think we're ignoring the elephant in the room, which is as soon as you have self-consciousness, the whole human being takes on a very different dynamic, because one has, the internal consciousness, which is, one could argue, the first experience one has of oneself, and one can structure one's life in a very autonomous way. At least we feel that we can do so. So I think that's always the strongest argument against determinism.
Yes, and if you can in some way detect what I am about to do or about to think, and if you tell me that, then I may well say, no, I'm going to do something different. Why should I do that? Especially if it's getting a bit awkward. I won't do that. So that's when I think, yes, you have got this flexibility coming into it, and your self-conscious certainly comes into it.
Tristan?
With cognitive behavioral therapy, are you actually, in effect, altering the chemistry of the brain with just a sort of non-physical treatment like that?
Well, I imagine the answer is yes, you can be. Does anyone else want to add anything to that? If you are going to respond differently than you would have otherwise, then I think the answer must be yes, you are. But it's not going to be nearly as precise, if you like, as actually doing it directly with altering level of neurotransmitter or whatever it might be, but indirectly you would be.
Yeah, but with adding a neurotransmitter, something like dopamine, you're flooding the whole brain with that chemical. You're not specifically targeting specific areas. Aren't you likely to get a somewhat different effect with a general treatment like that than perhaps something that's much more specific to a particular area of the brain?
I think it probably depends on how it's done. Does anyone else want to come in at that point? Bill?
I'm not sure that I got the question. Certainly, I would definitely say that flooding the entire brain with a transmitter is going to have a broader spectrum of effects than exposing a certain little circuit or a little region of the brain to a transmitter, because the same transmitters are used over and over in the brain for multiple purposes. So that is certainly seems to me to be true. But what was the deeper? I'm not sure I got the first part of the question.
Well, just with I mean, to me it's remarkable what cognitive behavioral therapy can achieve. It's a very dramatic effect often on behavior,
Yes.
which you wouldn't have really predicted, I don't think, from previous experience.
Yeah, so there's an the person who invented cognitive behavioral therapy, I forget the guy's name, but he just won a Lasker Award, which is amazing. The Lasker Prizes are the highest prize for medical research given in the United States, and many people who've won the Lasker go on to win the Nobel Prize. And the guy who invented cognitive behavioral therapy just won the Lasker Prize because it has been proven to be such a tremendously effective tool for treating depression and other mental diseases. More effective alone frequently than drugs alone. The best treatment apparently is drugs plus cognitive behavioral therapy. But to me, that's a huge argument for top-down control, because in cognitive behavioral therapy, you are working at the highest levels of the person's brain. You're working at the levels of belief. You're trying to change belief and change behavioral habits, and thereby create the changes in the brain that people seek to create with drugs from a bottom-up approach. And I find this really cool. I find this amazingly cool because it speaks to this reciprocal causality that I'm struggling to wrap my own head around. That working from the bottom down, at the highest level of organization, affects the system, but also working from the bottom up, messing around with the elements at the level of receptors and transmitters and neurons affects the system. But I thought it was remarkable that the Lasker Prize was given to the person who invented cognitive behavioral therapy. That's an amazing. We've come a long way from the 1980s when academic psychiatry was just totally bottom up, just totally tweaking receptors. We've come a long way since then.
That's very fascinating. I think what I'm going to say is, why don't we have one more question now, and then have a 10-minute break, and then we'll have questions for the panel. So if people want to formulate their questions for the panel, we'll do that and then reconvene. But maybe one more now. Oh, let's stop into silence. So maybe we will give Gareth a big round of applause.